All right. I guess we are recording.
Sweet. Having revised for a figure caption.
Nice. Oh, okay. Well, let's go. So I guess we can start by taking a look at the PR and just merging that. I guess we don't have to do much.
Yeah.
And I guess I'll invite you to Zig afterwards. But I guess first thing
I was wondering
we can do this.
so we added a commit for the vec3. I guess we can just commit it or merge this.
Yeah.
But I was almost wondering if we could just delete the vec3 stuff. I think there's only it's really small, so I guess it doesn't really matter. But I'm thinking we're starting fresh today. We really just put in 4 lines of code for that. And last week was really just putting in the ppm stuff.
Yeah, that's true. So, but I mean, I think it's fine.
Yeah, it's just us. But I think, when we open up the file, we can probably get rid of it and start from scratch, because I don't really remember. So.
Right, okay, so that's in main. And I guess I now want to switch back to main. What happened here? Oh, and then I do a pull. Will that work? Yeah, it does. And now we are on a main with everything.
Yep.
And then I'm just dumbly using the Git Kraken GUI.
Oh, cool.
And we are on week 3. Cool. That looks about right. So let's call Trevor.
Cool.
How does that look for you?
Good. My Z is like a light purple. Yeah, it's good.
Okay, so I mean, you mentioned you wanted to start fresh.
I figured this. Yeah. I think we copied this anyway last week from the
Zig documentation. Yeah. So Zig documentation, language reference. I remember it was by the struct. Yeah, that was the default example, vec3. But it is essentially what we're gonna need anyway, so we can just, I think, leave it like that. Because I was kind of wondering what's the recommended way how to implement structures like this. And since it's from the example, I was just assuming that's how you want to implement a structure, or it's not a class, it's not an object. I guess we can call it a structure with methods.
Yeah.
And we last time we were sort of wondering how does this work with the initialization. So I remember we were sort of learning that order, I guess, of the parameters is how you. Do you remember that?
So these don't matter. Right. The arguments that you the parameters that you define for the actual function, the ordering is whatever you want them to be. So they could be it could be y, z, x. But then they are. You figured this out. Is that if you pass them in as a lit, without any assignment operators, it's the order.
It's the order and then fields in here.
Exactly. Yeah. And so and then if you pass more explicitly, I think that's probably preferred. So that's why on line 9 we're just passing 0 for each of them.
I see.
We could be more explicit, but I guess it doesn't really matter in this case.
Yeah.
I think you'd have to do it for all of them. And then if it's this way, then it's just mapping, and that seems what's preferred.
Okay, so that's essentially what we lifted from the documentation here. And if we look back, so where did we actually end up? So we do have the book is talking about a vec3 class, about how it's different between like vectors and colors all have these four components, or three components in this case. And the book implements the vec3 class because it's in C++, and it's going to be used both for the positional or direction, like velocity values, as well as the color. So it has a bunch of these operators that maybe we need to figure out how to implement.
vec3. Okay.
Yeah.
So and it's a little bit tricky if I remember right, because right, they use like some operator overloading stuff, and we don't have those in Zig.
Right.
So,
but I guess we can take advantage of what we learned also about the self. So it's again lifted from here, right? Like we have, if we wanted to have a dot product, do you know how like Z, if they have automated formatting? Is that good?
I bet we'd have to like install. I think that if we here actually, I can't do it. If you open up your
Command J.
Command J.
Yep. And so now we're in, and then CD into ray tracing. And then I wonder if we're in Zig FMT. Try that. Let's see if that works. Maybe not. Weird that maybe it has to compile it the first time.
Does look like.
Did
anything change? That doesn't seem like it. Anyway, it was just a short thing.
Or maybe not dot. So Zig format and then source. FMT, sorry. FMT.
I see.
Source main.zig. That looks
but I already fixed it, so.
Okay.
That was manually formatted.
I think you can probably turn on that stuff. I don't. In Vim, I have something set to auto format, but I don't in Z.
Yeah. Okay. Let me see. I can just try to see CD ray tracing. So what's this? It's Zig build run, is it? Build run. So this is what it does. And if I want to pipe it, one thing. So we had this issue before where if you run the program and then run it for the second time, you get an error.
Yeah.
So I actually found out that this is like a regression, and they fixed it. So if you update Zig, I mean you will have to do the same thing, like you download the binary, but it is fixed.
Okay, cool.
But you have the new version.
I have the new version. Yeah. I had a note that like to mention it because I guess that's the interesting thing about working with something that's still evolving. And so sometimes it's actually not your fault.
Yeah, that's. I kind of assumed I was like, maybe it's like a quirk of the language where they're like, yeah. Nothing changed. Like it fails. I don't know.
Yeah. Okay. So for the operator overloading, let's say if we just do the simple one. Actually, let's do the plus.
Like add?
Yeah. I would do something. Okay, so let me see. I have multi-line comments. It's not a thing. Remove.
Looks like me.
Okay. Anyway. So this is the C++. And I'm gonna assume that we want to have, probably can use the plus sign as a function call. So we can just call it that, and then we do the trick with like self first parameter is this. other. I'm essentially copying whatever is in the dot product above.
Mm-hmm.
And so we should be able to call it. Do we have an example here? We don't, right? So is it const position A, whatever, is vec3. I actually don't know if this works. Oh, vec init. Okay. Init. 0, 0, 0. Or I'll just leave it like this. And then so we can do const position B. It's gonna be, let's say, 1, 2, 3. And then the add function we would use like host A post B. And so I guess we wanna return actually a vec3 like this.
So
as one thing I noticed about the implementation for C++ is that it passes in. Is that a reference?
It looks like a reference.
So are references automatic, or would we also need to pass in? Like would we also need to? Does in Zig we need to pass in a reference to the vec?
I don't think so. I'm actually wondering why it is in there.
Well, like the Zig, I'm curious if this is not owner.
Because the thing is, like with the V, you're not really editing in any way.
Right.
I think it's just that this is gonna be a pointer type.
Right.
Like you're gonna dynamically allocate the vectors, and so it will always be pointers, and so you are gonna. It's just C++. I think doing C++ things.
Okay.
I think this is totally okay. So if we do, okay, so we're gonna. I guess we're gonna want to return a new vec3. Then we're gonna init with self.x plus other.x. And the same thing for all other.
I don't have my. Normally, I can like find and replace on the line. Like I don't know the key binding. Okay.
So this should essentially work. I wonder where I can just output it. Let's put it at the end of the. Oh, this could actually be in like a test, maybe.
To assert with the.
But it's probably.
Let's see.
Later.
Maybe we can. It's easy enough. We could write our first test.
Okay, so there's an expected function variable declaration. What did I do? Oh, I guess it's because.
Right. That's my fault.
Okay, another one, unused local variable. Oh, okay, so this is just about. I wanna. How do I std.debug? Different.
I wonder if it'll know how to format the thing. Because it's a complex type.
Oh, sure. Well, I can like deconstruct.
Do the different fields, yeah.
Okay, so res equals, and then it will be this. this. Let's put some commas, and then it will be res dot. Can you actually access it like this? Or is it private by default? Expected
we have zero. So we have init, and we also have empty or zero? Origin.
Okay, so init. So this is gonna be. Oh, let's just so that we see some. So that we see an actual addition. Function declared here. Okay, so this is expected. Print.
Oh, you put in like a table, like up there.
Ah,
so it's like
I see.
Yeah.
Oh, wait. Can you see the console if I'm doing this vec3?
I don't think I can see the console. No.
Okay. Well. Anyway, I guess I can do it using build run. And I don't see the. Oh, okay.
There it
is.
Looks right.
I think.
Because it's all. Oh yeah, it's 4. Just particular that it's in the middle.
What?
Right.
It's interesting that it's the debug outputting.
It got
it's intermixed with the standard output.
Yeah.
And what is the other one? std out and then std debug. So maybe I can directly start running things like I'll put it in ppm and then
okay. I'm trying to write a unit test for what you just did. And we can see. So
alright, can I see it? I think I can, right?
at the bottom of the file.
Nice.
And I was just trying to see if there's a is close or something like that.
Oh, for floats.
Floats. Yeah.
Did you try?
I can't. I don't think I can run it.
I have to run it.
Yeah. I don't
I don't know if it runs it test or what.
Zig test? Run build?
Maybe it's just like zig test.
I know it was one of the zig test. Oh, you have to specify.
Zig test source main dot zig.
Yeah. Zig test source. And that's the main dot zig. Unused. That's because.
Okay. So I got this float approximate equal thing from ChatGPT. It's not a real thing. It's hallucinated.
Yeah. I think that's safe to say that for Zig, using ChatGPT is
Probably
totally
bad.
good because I think sometimes you can even find like GitHub or Stack Overflow questions that are just not correct.
Right.
So what did we learn last time? There's like float.
I would just
cast it to like
an
an int, right? So we can just do
that.
that. So we can do stood dot expect stood testing. We learn. Okay, yeah, I learned up here.
We have
float int from
float.
float. So I'll just take that. We can do stood testing expect. Result.x. I'm trying to remember. In the Zig guide, they have like, you write like expect. Okay, you just write an equals.
Yeah?
4. Okay.
Oh.
I think it's fine that we just cast in this case, because
in this case, yeah, but
All
right, can you we can just try it. Oh, I see. Okay, go for it again. Oh. It's interesting that these are compile errors.
Okay.
Error union is ignored. Consider.
Is there an error that happened? Let's see. So Zig error is
STD testing expect. Planet Parenthood. How does STD work? Testing. Testing. Zig test. Okay, test declaration. I kind of like that you. I like that even we are dealing with the testing right from the beginning, and it seems like it's very much encouraged by Zig itself.
So if you run Zig build test, this will actually run it for, I think for the whole, like it'll crawl the.
Because it has we have the build file.
I think so. Yeah. So that way you don't need to say exactly what file you're doing. And then you can do dash summary all. Like dash summary and then space all.
Okay.
And I think this will get back like a nicer.
Looks pretty
warning. Okay, and we've got the same thing.
Error
union is ignored. I'm just curious where the union is coming from. Because it seems like there could be an error, and maybe it's coming from the. I wonder if we can just do. This like. But in here or at the beginning? Oh, maybe it's try. Yeah, sorry. Here at the beginning of the line.
Right.
Okay. So it seems like stood testing.
Yeah.
Okay, cool. So I looked into this last week, and Zig has a really simple idea for you can't. It's similar to Rust. You can't throw errors. You return errors. And so the try syntax is this way of like short circuiting. So
you
I think in Zig you
do
can do
this
this
thing
thing where you like try, and then over here you could write a catch and do something else. So
we
we could say like, imagine that this is like a fetch request or something like in the browser. You could try fetch to fetch something, and then if you catch an error, then you have to handle that case. But it's not the same way that in like JavaScript you like throw and that bubbles up. It's when you try here, it returns from the function. So the thing that you get back, I think here is actually like a result, basically, or it's a union. And then you have to handle either side of the union, which could be like it worked or it didn't. And the try syntax is just like a shorthand to like unwrap it and fail early. So if it were to fail for whatever reason, it would just bubble up, and something in the caller would have to handle that other side of the union.
So do you get like types?
I don't, not in
Zed,
Zed.
right? I guess that's something that we could also see from the types, but I guess it's pros and cons. So
we might be able to do it with we might be able to do it if we did. We could try VS Code only too.
True.
Because I bet that might have a.
Oh yeah. Okay, so that seems like it's somewhat working. And the thing I started adding here is like an inverse.
Okay.
Where you essentially just multiply all the elements by -1.
Okay, so that's this one here.
Yeah, exactly. Okay. And so like the thing is, how do we express that?
So we would return a new vec.
We'll return a new vec, and then I guess you just do self that x, self that z minus I guess that works. Okay, but even in a C++, it's like a minus operator. It doesn't mutate the structure. It just returns a new one. That's inverted.
Yeah, I don't know if in here you need, if there's like a mute keyword or something like that, or maybe you just mute it. Or you like self.x minus equals like self.x or something like that. Okay.
So maybe I think it's like minor, but instead of invert, it's like invert this vector. You just do inverse, like return the inverse.
Right. Okay.
I think that's the convention from like the vector libraries that I know.
That makes sense.
What other things we have here? So obviously, like the accessors, we don't need to have because we can access the XYZ directly.
Below the inverse, these look like scalars.
No, this is just an operator for the
getting back.
Yeah.
Okay.
Array accesses.
Like for the which we probably don't need either.
I think so either. Okay, there's a kind of multiply by scalar. So that could be like scale vector. And again, like return, I guess scale, maybe. Okay, then it's gonna be okay. It's not gonna F3.
But this one actually mutates it, right?
This one actually mutates it, yeah.
And it also looks like the so we have add, but then we also have this one where it takes a reference, it adds. So scaling multiplication, and then what would the I'm looking at these two because we have up here. Or no, maybe add. This is add, right?
This is adding two vectors.
but it returns this.
Oh,
So
actually, yeah.
so we should update this one to be.
But I don't know if it's not that. I see. So maybe that's the issue, because you're gonna end up with like vec3 dot add vec3. I think it's totally fine if you go like this. You just always gonna assume that you are getting a new structure.
Yeah. I say let's go with that. Usually the only reason you want to avoid that would be like if for whatever reason allocating one of these things is like super expensive, but I don't think that's really what we are caring about. And it's easier to think about it. Also the nice syntax of like being able to save this one plus the zig thing that you're showing there, where you can choose to pass it itself or not. It's nice.
Yeah. So I think we can just keep it like this. Not mutating like yourself. You are just here. I'm almost wondering if these don't have to be inside the structure. Like what do you get by having it associated?
I guess the convenient thing is that you can pass in another vec, and you don't have like. If we'd had those things on the outside, then we'd have to repeat ourselves. But this way, where we call this other places, we can call inverse and scale and add, and the implementations are here.
Okay, so in this case, we can do like self.x times self.y times s times s.
Right. But I do think so. Also in this operator overloading here, they have divide, which is just syntactic sugar for calling scaled with the inverse. So I don't think we should implement that one. We should just call scaled with 1 over whatever.
Yeah.
And
then the length. So it's pretty similar to like it. Yeah, that's interesting. Do they not have a dot product in this?
We implemented it.
We implemented it, but
they don't have it.
Yeah, we took it from the zig documentation, but actually like length square, that's dot product.
Okay, so wait, where's do they have stood? Let's look up zig square root. Math.zig. Here we go. But do we want to call it dot, or do you want to do?
Say again?
Like the dot product with itself is the length square, right? Or is that what you're saying? Yeah.
Oh, yeah.
Because don't we have dot or no? Yeah, we do have dot. So we could so we could just do vec3. Like I think for length we can do return vec3 dot self and then square. Right.
Well, actually, so like this. And here you do like 3 at the length square. So is it like this?
But length squared doesn't take in a. I see what you're saying. Or you could the alternative would be here you could call self like this, right?
Oh yeah, true. Yeah, true. I don't know what's better.
But I guess I was just curious. I'm curious where if they'll call length, like if they wrote this function. Sorry, in ray tracing the weekend, like if we go to with length squared. Do they use that elsewhere? Okay, they do use it elsewhere. I just was like, is it a private function that like,
no.
but it makes sense.
Yeah, I think as far as I know, it's just like square root is in general a pretty expensive operation to make.
Okay.
So sometimes you can, I'm wondering, like the dot product. Yeah, I guess this comes just from the graphics context, because dot product, I think it's quite fast. It's just what, 3 multiplications and an addition and 2 additions. 1, 2, yeah. And square root is much more difficult, so sometimes I just use the length square as a measure of how long it is without actually figuring out the length.
Do you mind if I write this longer?
Go ahead. Yeah, no
problem. Let's try to compile.
I think
if we do Ziegfeld test, so
okay, so we got there.
Expected return type expression file.
So on length 3 it's
S32, I think.
Oops. Okay, cool.
Oh yeah.
Yeah, it's interesting. So you're saying square roots in general are expensive.
Yeah.
So in the Zig standard library, they've inlined a bunch of like square root of 2, square 1 over square root of 2. I think just probably so you don't have to. Even though I think in Zig you could definitely do these as comp time things, though, right? You could. And then those would just be in your binary. So, but maybe these are just convenient. They're like numbers that you want.
Yeah, I wonder if we're gonna get to the place where we actually need to draw some stuff and like figure out the linear algebra.
Yeah.
Okay. So let's see. So we got our vec3 class. Or sorry, struct.
Yeah. And then you have, I guess they can type def the vec3 to point3 as sort of a differentiation between vector3 being used as a color and being used as a position.
Okay.
And the question is how to do that with Zig. Maybe it's even in the struct.
Here,
struct alias. So I think we could go down here.
So you can yeah, it's very simple.
So say point 3.
Yeah. Seems to be working. And then in that case we can then do like point 3. Yeah, there's a bunch of other vector utilities. Yeah, I guess arrow 1 is pretty useless.
Which one? Sorry.
There's like the vector utility function. It's like the first one is sort of outputting it to, like you print essentially like printing it nicely.
I wonder if there's something that you can, if you can implement your own. So we don't have to unpack the vec. We could like nicer.
Kind of like two-string.
How to print structs with strings.
Zig. Format function.
So it looks like on your, if you implement format on it. So I'm going to just copy this here. And the first argument will be write all new vec3. I guess it's a little tricky. X, Y, Z.
Right all.
And this will be self X, self Y, self Z. I wonder if we go into this main loop at the bottom. Let's see. So maybe we can put this debug thing at the bottom, and we can just try to print our. Oops. I wonder if you need to pass in like D or something like that. But what comma's missing?
Invalid format string.
Maybe I did something. Oh. Oops. Okay. I copied it. Okay.
That's pretty fine.
Maybe we could come up with a nicer, or I'm wondering if rather than like, there's like a, we could just do like a one-line thing instead. And then dot self.x, self.y, self.z.
Right.
Function expected one argument and got two, so maybe the first thing you can't actually.
Well, how was it before?
So the right, maybe write all is for one where you don't actually pass in any data.
Yeah,
So
I was wondering what's the difference.
So maybe we'll just need to do vec3 x, y, z, x. And then we can just get rid of those other lines.
Oh, okay. Yeah.
Okay. Nice. Maybe I should put a new line.
Nice.
Okay. Cool. Now we have a nice.
So it's like something that you overload.
It looks like some
maybe it's like you have the
convention, and maybe
there's like a comp type. But yeah, it's interesting. In Rust, this type of stuff, you define it's called like shared behavior with these things called traits. So like for this struct, you'd implement a trait that's called standard debug that you implement format. And it seems like it's way simpler. You just maybe it's like a convention. And I'd actually be curious if you implemented a version of format that didn't have like that signature, what would happen? So if I wrote a function called format that was like took in an int or something like that. pen format.
Yeah,
Yeah, see, it's not even in the.
I couldn't find it. Okay, then. Yeah, it does seem like the utility functions for vectors are kind of repeating themselves. So like there is a scalar, scaling operator. There's even a multiplication. If you okay.
Oh, sorry.
No, that's okay. Like if you look at the, I don't know, like 1, 2, 3, 4, fifth one.
Right, so we've implemented all of these.
Well, so I think we've implemented most that we should need.
Yeah.
Because there are these that don't really make sense. Like you have, oh no, okay, this one. Like you have two vectors, and you multiply just like the component wise. I don't know when that would come up.
Yeah, it might be nice to actually be like explicit about if you are using that version.
Like
these are all helpers.
Yeah, I'm just wondering, like, because it mathematically doesn't really make sense as far as I know. Maybe. Who knows? But I think like it's safe to kind of skip most of these. Maybe the division, but I mean anyway for division we can just do like multiply by the inverted value. So I think that's totally fine. The other things are dot product we have, and then cross product. Cross product we can, I guess, implement. And then there's this like make the vector unit vector. So I guess those are two things that we might still want to implement and use. What's the curious thing? I don't know why we still have, like, why this is defined as vec3. But then this like alias as a color. So you still have in the color, you still have like a dot product. So you're doing dot product with colors.
Right.
It almost seems like it's like you should want to implement that, or like you'd want.
If
you'd want to define different methods for the different semantic usages of the data.
If you're already differentiating the semantics between a vector as a point vector as a color, you might want to already incorporate that in the type system. But maybe that's just like C++.
Yeah, or it's like more convenient to.
Yeah,
I guess we'll encounter that. Okay, so let's see. Cross product. So cross product is going to be two vectors, self vec3, other vec3, and then what it is this thing that we are.
Another vec3.
Another vec3. Yeah.
I'll take one of these lines.
Yeah, okay.
Take the last one.
So then that's cell dot x. No.
I
just copied the line, and then
like one is y, two is z.
I think so. What is E though? Is that just to get a reference to the vector, like the array type? Like what is dot E?
Yeah. Dot E is just like the vector.
Okay. Weird. But I thought they implemented the overloads to get.
True. That could be useful to use in this case.
Like it's like the actual getters would be nicer too. Okay. And okay, so self. Other. Self. Other. X.
Why do we have a? Oh,
Yeah.
Nice.
Nice.
Yeah.
Yeah.
So that's the cross product, and then the unit vector. I wonder how to call it. So normalized. That's normalized. So we're going to sell vec3, return vec3.
Oops, sorry.
No, it's okay.
I'll implement it. Okay, so we can use vec3 dot scale. Is it scaled? Is that what we did?
A scale is for a scalar. So what you want to do is...
But I think this is...
yeah, true. Yeah. So it's scaled. So it's scaled self. Yeah. I think that's correct. And I guess you can unit test it. Because this is something like if you have some random vector and you normalize it should have a length of 1.
Normalize. So what should it be? So if we have our const vec is equal to vec3 dot init, and
just do like whatever, random, even big numbers. Yeah. 1, 2, 3. And if you do so, you can just write the expression. It's gonna be
and it should be 1.
Yeah. So then you are just in vec dot normalized. Dot length. Yeah.
Like this.
Yeah. Yeah. Oh, I need to do zig build test.
Oh, that's
I put that in there.
Habit.
Yeah. There. TypeScript. Oh, semicolon.
That's also something that definitely JavaScript
It doesn't care about.
Module name math import.
I thought that worked fine before.
Did I?
No, I think I changed something. We try this. Oh no, what? Not stood. But then I think I had to do like dot script. Okay. That. Okay.
No, but okay. Let's see.
I think you have to do that zig. Okay. I'm just curious.
In-depth overview. STD. Why is it STD map?
Maybe they just have it on a namespace. So you just. I thought that we had to import from something else, but I guess it's a part of the standard library. So if we do script, so it's stood.math, that's good. Okay.
Length square. No.
Oh, length. Okay.
One more error. No scale. It's a scaled.
Scale. Oops.
So one zig build test. Unexpected result. So this looks like a test that just didn't succeed.
Mm-hmm.
And the question is, shouldn't it tell you like why? What was the value?
So I think it just like I'm wondering if there's like so the issue that I can see with this expect is that you give it an expression. So it doesn't have like a notion of like left side, right side. It just has equals. So it'll just say expect true, expect false. But like it won't tell you what they were different. So I'm wondering if there's like a zig. Expect equal. That might be what we want. Because then what we'll get is like a, so we can expect equal, and rather than passing this in, and now we can say it might be able to tell us like, okay, on this side you want this.
Wait, but this is something on normal.
Expected
zero found one.
Where did you find one?
So sorry. The first argument, I'm going to flip it around. So expect equal says expect this to equal. Sorry. The expected thing is on the left, and then the unknown thing is on the right. But I just flipped it. So before, when if you run it again, now we should get a different. It should say expected one, thing found zero. So it means what we're getting back is zero.
Oh, okay. I thought it's like like expected one argument on zero.
No, we could like I think if this, I don't know. Yeah. If you run it again,
it should be like expected 1,000 and got
Right. True. Okay, so n length. Okay, so normalized length.
It could. I wonder if it could it be that in float, if we want to like, if it's around, it's like truncating.
It could be
Like if it's like 0.9999.
Maybe we can. Can you in a test just output to std debug?
Let's do debug.
It's in the normalized. Okay. How long are we actually recording? Oh, 58 minutes already.
Okay. That works. There it is. Right there.
Do you see?
Whoops! I printed the vec, not the length. You can see that. There's a nice little thing. And so, okay.
Maybe put a new line.
Yes.
Okay. So it's truncating it. So I wonder how you do like round.
Just we need to figure out how to. Yeah. Zig. Managing floating point.
Okay, there's something called like at round.
At round, I see. Away from zero. Okay, so we do
Instead
of
of
into
float,
you could do maybe add round.
So
instead
instead
of just this,
I
yeah.
think
I
we
think
could
we
maybe
maybe
try
try
round.
round.
And
And
then
then
I'm
I'm
guessing we have
guessing
to
we have to
cast it.
cast.
So
Do you?
well,
Well,
we
we
can
can
see.
see.
Expected type use iPhone.
Hmm.
Oh,
Nearby.
maybe it doesn't cost it.
Yeah, so it might just do exactly what we had before.
You still need to do like, yeah, okay. So it rounds it, but it doesn't cost it.
Oh, there's a seal. What does seal do?
Oh,
Oh, but these are all for all floating point. Yeah, so it doesn't cast. Okay, so
I don't
I don't
know
know
if
if
this
this is
if we're
if
gonna
we're
get to
gonna
the
get to
bottom
the bottom
of
of
this
this
Yeah.
right now.
but
But
I guess
I
we're
guess we're
learning the
learning
hard
the hard
parts of
parts of floating point numbers.
I mean, now I didn't get I don't know what run test is DDR. What if I just don't put DD? Is that like passing? Before it gave you something, right?
Oh, can
Oh,
you
can you
do
do
dash dash? So the dash dash summary all maybe we'll see.
Okay.
So
So
okay.
I guess it rounds, but it still remains a float, so you need to cast it from float to int.
Mhm.
But this is so clunky. Like,
maybe
up on this
line
line we could do round
like before there.
there.
I mean,
This is clunky,
but also
this is floating.
We're
We're
looking for in
in general
comparing exact numbers for
yeah.
floating
floating
point
point
stuff.
stuff.
It's tricky.
Okay, well, but this seems like our normalized and length functions seem to work.
Yeah.
Cool. Well, let me see. So I'll just what would this be?
Do you want
Do you
to
want to
run
run
Zig
Zig
format?
format?
We
You can get
Sure.
Zig FMT source.
You know what? I just want to see how it actually changes.
Oh yeah.
So let's see. What were these like? Is it a feat? Or is it a char?
Yeah, I think it's a feat because these are completely new methods.
Vector-free methods, let's say. I'll commit to week3 and then zig, FMT, and I'll do main zig.
Source main method.
That's interesting that we didn't do any
SRC.
SRC, yes. Okay, there are changes. That's fine.
Mm-hmm.
So that's a chore. Zig, FMT. Okay, and I can push.
I was gonna just do one last thing. I just removed like some unused methods. Comment out stuff.
You can
look at the diff if you add something. He implemented those, and I just got rid of it. I guess we could keep the debug if we wanted to, but
no, that's fine. So okay, and
this I'd say would be like a chore.
Chore. Delete. Comments. Okay, cool. In that case, if we look up in here, I can make a pull request week3. All right. Well, that went by pretty fast.